Hi, Assalamualaikum. My name is Muhammad DANISH bin Johari. My matrix number is B0920104003. I'm going to talk about the introduction about machine condition monitoring fault diagnosis gear. So it has a rich history that has evolved alongside the development of machinery and industrial technology. Early method relies on manual inspection and visual observations, but as technology advanced, sophisticated technique emerged. So today, the field has undergone a revolution thanks to the integration of advanced sensor technologies, data analysis algorithms, and machine learning technique. The introduction of vibration analysis, acoustic image analysis, and thermography has significantly improved the ability to detect gear fault at an early stage. Moreover, the digitalization of processes and the rise of the industry Internet of Things, we call IIoT, have transformed gear monitoring. Through sensor networks and data transmission, real-time monitoring, predictive analysis, and remote access has become possible, enhancing the overall efficiency and effectiveness of fault diagnosis. The theory behind machine condition monitoring and fault diagnosis for gears encompasses various approaches, such as vibration analysis, acoustic emission analysis, thermography, oil analysis, and the utilization of machine learning and data analytics. But here, I'm stated down for three methods only. By employing this technique, engineers can detect anomalies, identify gear defect, and predict foundation failure, enabling proactive maintenance strategies and minimizing downtime. So overall, machine condition monitoring and fault analysis has revolutionized the field of gear maintenance, ensuring the smooth operation of machinery in industrial settings. So that's all from me. Thank you.
Bismillahirrahmanirrahim. Assalamualaikum. My name is Muhammad HAMIZAN bin Muhammad Rizwan. Today I will to talk about definition for machine condition monitoring and fault diagnosis for gear. First of all, machine condition monitoring and fault diagnosis for gear system is aimed to detect, diagnose, and predict the fault in gear to improve reliability. So there's uh, several diagnosis technique for the gear fault, but this is four that usually been used. First is which is vibration analysis, monitoring gear vibration to identify potential fault like tooth gear, tooth wear, pitting, and misalignment. Second analysis, which is spectral analysis to analyzing frequency content of vibration signal to determine specific fault types. And the third of diagnosis technique, which is acoustic emission monitoring, to detect high frequency acoustic signal to identify faults like tooth wear, chip teeth, and cracking. And lastly, that usually been used is lubricant and wear debris analysis. That been analyzing lubricant and debris to identify fault and predict potential failure. And lastly, machine learning technique for gear fault diagnosis, which is using machine learning models trained on gear vibration or acoustic emission data to classify and identify potential fault in real time. That's all for me. Thank you.
Hi, Assalamualaikum warahmatullahi wabarakatuh. My name is Ahmad Izhamin Arfandi and I will continue. Why does it important? Because first, it can prevent unexpected failure. Second, it can influence on productivity and profitability. Because if we prevent the unexpected failure, it can make our machine works well and doesn't have any kind of machine failure. Second, it shows performance of gear. By showing the performance of gear, we can conduct a PDM, which is predictive maintenance. So we know when do we have to perform our maintenance. And lastly, a cost saving. Every company have a budget. So by having a foresee of our machine downtime, so we can make our backup budget. So it can thus it's saving our cost if it doesn't have any corrective maintenance, because corrective maintenance has cost so much cost consumption. Next is how to measure the failure on gear. From here we can see the gear teeth on the peak temperature, which are the picture quite bright. So we can conclude the cause of the peak heat, which are when the gear teeth touching each other, it creates a friction. Friction creates heat, and heat can make our gear teeth worn or damage our gear teeth. Before anything happen, worsen our machine, so we can perform the preventive maintenance thoroughly. Before I'm going for frequency analysis, important notes are the selection of measurement techniques may vary depending on the specific gear type, application, and monitoring requirements. Next is frequency analysis. From the amplitude, we can see the graph are quite fluctuated, and by watching the amplitude 1 time, 2 time, and 3 time GMF, it we can conclude that it may have a problem in gear or opinion. So it's also important for the sideband around 1, 2, or 3 GMF at the frequency of 1 RPM of the worn gear. As we can see from the sideband, we can see the graph are quite fluctuated, and at first it's low, and then it's gone high, and lastly it's not quite reliable for the gear. So from here, the peak corresponding to the resonant frequency or of the pinion or the gear has shown the gear are not in the good condition, so that we can foresee our analysis of the gear is not really in a great condition. So that's all for me, and I will continue for the next person in conclusion. Thank you.
So, hello, my name is BRISSCO Dimersi Jamisius, and my metric number is B0920102447. So, in this part, we're going to talk about the conclusion. So, in a conclusion, the diagnosis play a crucial role in ensuring the reliable and efficient operation of the gear. Generally, if we look anything that involves gear, need a diagnosis, analysis, and monitoring for how it's operate. So, what do we get when we operate, we monitor, and we analyze the gear? So it's offered to detect a potential faults and any abnormalities. So potential fault and abnormalities can be detected early on, allowing for timely maintenance and repair action. So anything that involves gear need to be monitor to detect an early fault or abnormalities. So if we detect the abnormalities, we can timely the maintenance, and the repair action can be done quickly or early before it's going to be a downtime or a breakdown. So uh, the condition monitor and fault diagnosis also helps to prevent a costly breakdowns. As I told before, the potential fault detecting the potential faults helps to reduce uh, downtime, extend the lifespan of the gear, and prevent from a costly breakdown. So monitoring is very a crucial part on monitoring any system or uh, things or machine that involves gear. The technique that use uh, it will mitigate the risk of catastrophic failure, uh, equipment damage, and safety hazard. So if we monitor it periodly, not regularly. Regularly means it's more costly. So periodly, it's timely maintenance. So the risk of failure will become lower because failure become lower, the equipment damage is getting lower, and the safety hazard is getting safety getting higher because the work environment is done properly. Not forget to mention that it can empower the industry to enhance productivity, optimize maintenance strategy, and achieve higher levels of operational excellence in their system. When we do the this condition monitor and diagnosis, we can detect early abnormalities, faults, and then we can prevent any breakdown. So the industry will enhance the productivity of the product and optimize the maintenance for their strategy. So that's it from me. Thank you.